we want to identify the constant of proportionality in graphs. Let's say that you're taking a road trip, and this is a graph of the distance you've covered and the amount of time it takes you to cover that distance. So we want to determine the constant of proportionality, which is k. So let's remember k. What we know of it is that k equals the y coordinate over the x coordinate, and interpret it in context of the problem. Well, we can just put the y over the x if it's directly proportional if it meets two standards. Remember, so one standard, or the first thing, is that it is linear, meaning that all the points on the graph form a straight line, and two, that it goes through the origin. And you can see in this graph that both of those conditions are met. It is straight, going in a straight path, and it goes through 0, 0. Therefore, the relationship is proportional. It varies directly, all the ways that we've said it, and since it is directly proportional, or varies directly, we can choose any point on the graph and find our constant of proportionality, except for 0, 0, of course. 0 over 0 doesn't give us anything. But really, I'm going to look for convenient points where they cross both the x and y, the vertical and horizontal lines. So any of these points would be good to find your constant of proportionality. So I'm just going to take this one right here, just because I'm looking at it. And again, all I have to do is put the y coordinate over its corresponding x coordinate. So k equals 300 over, or divided by 4. And when I divide that, 4 goes into 300 75 times. So my constant of proportionality is 75. Now it doesn't ask me to write an equation, but just by my nature, I got to write the equation. So y, which is the distance, equals 75x, which means 75 times the number of hours. Now sometimes that helps me understand because I do need to interpret the constant of proportionality. And what this constant of proportionality means is that the driver, or that the car, or that the family, whatever it is traveling at 75 miles per hour. And the thing is, we could have used any one of them. In fact, this one right here is exactly that ordered pair. I mean, here's 75 right here in 1 hour. And then this is 150 miles in 2 hours. And then 225, oh, I skipped this one. No, I did that one, I just didn't draw the line. So 225 and 3, 304, and then 375 and 5. I mean, you can see that all of those ratios would equal 75 miles per hour.